Apple Aqua, Windows Aero, iOS 7, and now Apple Liquid Glass. 4 releases separated by a quarter of a century. Everyone introduced transparency as the future, and everyone eventually had to calm it down. Transparency reveals what sits behind an interface, but if it reveals too much, the interface itself begins to disappear. This is the paradox of transparent design. The effect that makes an interface feel most advanced can also make it hardest to use. Real glass has never been one material. A window disappears, a bottle shows you enough. Privacy glass shows you nothing and still lets light in. Apple's original Aqua interface arrived in 2000s. Its buttons looked like polished candy with highlights, reflection, and translucent layers. But Aqua's transparency was mostly theatrical. It looked like glass while behaving like a solid surface. Its purpose was to make digital controls feel physical, understandable, and inviting. Transparency supported that illusion without taking over the interface. A few years later, Microsoft pushed the idea further with Windows Aero. Aero made graphics hardware visible. Windows blurred whatever sat behind them, reflected light, and appeared to float above the desktop. With Aero, transparency moved from decoration into the interface hierarchy itself, and this created a problem. The more content appeared through a window, the less clearly that window could communicate its own boundaries. Text competed with backgrounds. Controls blended into whatever happened to sit behind them. Visual richness began to undermine visual structure. Microsoft gradually reduced the effect. Some surfaces became more opaque, while others lost transparency entirely. The glass remained now confined to a supporting role. Then Apple made the opposite move. With iOS 7, it removed much of the texture and physical detail that had made previous interfaces easy to distinguish. Leather, paper, felt, shadows, and raised buttons disappeared. To replace that lost hierarchy, Apple introduced translucent layers, blur, motion, and depth. The collection of physical objects gave way to sheets of light floating above one another. But once again, transparency created the same conflict. When the background was colorful or visual complex, text became harder to read. Layers were elegant in motion but ambiguous in still images. Controls sometimes looked less like controls and more like decoration. Apple began adding ways to suppress the effect. By iOS 7.1, users could reduce transparency and increase contrast. Translucent surface became more solid. Colors became less dependent on whatever happened to sit behind them. The future of interface design had arrived with transparency and immediately required an option to remove it. The same pattern appears far beyond Apple. Google's material design avoided continuous transparency almost entirely. Material created depth with the solid layers and shadows, keeping the actual content behind each surface out of view. A card could appear elevated without allowing the screen behind it to interfere with its contents. This was a crucial distinction. Google preserved the idea of layers while removing much of the uncertainty created by real transparency. The interface kept its depth under the designer's control, independent of whatever happened to sit behind it. If you enjoy this kind of deep dive into the hidden logic behind familiar interfaces, subscribe to the channel. That is exactly what I make videos about. Microsoft eventually reached a similar conclusion. Windows 10 introduced Acrylic, a translucent material that combined blur, tint, noise, and control opacity. Acrylic turned translucency into a controlled recipe, limiting how much of the background could interfere with the foreground. And Microsoft built Restraint directly into the material. Acrylic could become solid in high contrast mode, battery saver, or on weaker hardware. Transparency had become conditional rather than absolute. Windows 11 narrowed its role even further. Translucent acrylic was largely reserved for temporary surfaces such as menus and flyouts. Permanent surfaces used Mica, a material inspired by effectively opaque layer that sampled the wallpaper without revealing the windows beneath it. Microsoft gave each glass material a specific role. Temporary surfaces could be transparent, permanent surfaces need stability. And then Apple introduced liquid glass. At first, it appeared to return to the most ambitious version of the idea. Liquid glass went beyond blur, refracting, distorting, illuminating, and responding to the content behind it. Controls could behave like lenses. Highlights move across their edges. Elements merged, separated, and changed shape in response to interactions. The glass itself appeared dynamic, and that made the old problem more dramatic. Liquid glass turns the background into an attractive part of the material. The material can bend text, amplify colors, create highlights and change its appearance as content moves beneath it. The result can feel remarkably physical, but it also means that the legibility of a control depends on an environment that is constantly changing. A transparent button changes as the photograph shifts from dark to bright. A navigation bar behaves differently over empty space than over moving text. The interface continuously renegotiates its appearance as the content beneath it changes. This is what made the first version of liquid glass so impressive and so difficult to use. Apple's solution was not to remove the material. It was to teach it when to stop being transparent. The first major correction was Restraint. Glass became more opaque behind important text. Background detail was suppressed where it interfered with the controls. Some layers gained tint shadows or stronger boundaries. Apple also introduced clear and tinted appearances. Clear preserved the most dramatic version of the material. Tinted increased opacity and contrast. This was significant because Apple had turned Restraint into a user-facing design choice. The original vision remained available alongside a more controlled version of the interface. In iOS 27, that Restraint becomes systematic. Transparency becomes a variable tuned across the operating system according to context. Different surfaces can use different layers of opacity depending on their function, content and context. A decorative element can remain highly transparent. A control that contains text may become more solid. A temporary overlay can preserve a stronger glass effect, while a persistent navigation surface needs greater stability. This is remarkably close to the compromise Microsoft reached with Windows 11. But Apple's approach is more dynamic. Liquid glass takes a more continuous approach. Its behavior can adapt from moment to moment. The glass itself does not disappear. The information beneath it does. That distinction makes iOS 27 a refinement rather than a rollback. Apple preserves the glass-like behavior: refractions, responsiveness, light bending, and shape changes. What changes is the amount of visual information allowed to pass through it. In optical terms, the material remains complex. In informational terms, it becomes simpler. This is the central change. The first version of liquid glass treated transparency as the identity of the material. The newer version treats transparency as one of its behaviors. And behaviors can be controlled. This is why the updated system feels more mature. It finally behaves like the real glass from the beginning of this story, a family of materials shaped by purpose. The first liquid glass behaved like every interface element was a window. The new version begins to recognize that some elements should be lenses, some should be containers, some should be simply surfaces. This is the lesson interface design keeps relearning. Transparency is excellent at creating continuity. It connects layers, it preserves context, it makes screens feel deeper and more spatial. But it is bad at creating certainty. Certainty requires boundaries, contrast, hierarchy, and predictability. Every transparent design system eventually has to decide which of these matters more in each moment. Aqua solved the problem by keeping most of its glass visually expressive but functionally solid. Aero exposed more of the background and then gradually retreated. Material design simulated depth without relying on transparency. Acrylic made transparency conditional. Windows 11 restricted it according to the role of each surface. Liquid glass is attempting something more difficult. It wants to preserve genuine optical behavior while controlling its information consequences. That's why iOS 27 matters. In iOS 27, Apple makes that material system more legible and gives user final control over one of its most consequential properties. The path from Aqua to iOS 27 is the story of repeatedly discovering the same limit. First, we made pixels translucent, then we blurred them, then we made transparency context-aware, and now we are making it adjustable, liquid, responsive, and finally restrained. This may look like a retreat from the original ambition of liquid glass, but technological progress often works this way. The breakthrough arises not when a system does more, but when its creators finally understand what it can stop doing. The same thing happened in robotics. In 2002, MIT AI researchers rejected the idea that a useful household robot first had to understand an entire room. Instead, they gave it the cheapest sensor possible, a strip of plastic that simply told the robot when it had hit something. That apparent step backward helped create the modern robot vacuum category and changed consumer robotics forever. If you want to see the same pattern unfold outside interface design, watch this video next.